Now let's talk about hypothesis tests in regression. For simple regression, two hypothesis tests are conducted. These are significance tests for the estimates for alpha and beta in the general regression model. So at this point, hopefully you're wondering to yourself, well, okay, that sounds good. What's alpha? And what's beta? And what's general regression model? Well, okay, let's talk about that then. First, remember our prediction model. Y hat equals A plus B times X. This describes what's happening in the sample, but we want to know what's happening in the population because samples lie. The regression model for the population is called the general regression model. And in this population, A is symbolized by alpha, and then B is symbolized by beta. And the prediction model is modified to become the general regression model, where we get something like this. Now notice that Y has been, Y hat has been replaced by Y, where Y is an actual value of Y in the population. Y hat is a predicted value for Y. And then now we have alpha, where it used to be A, and then beta, where it used to be B times X, plus we have this new thing right here. And that symbol that looks like an E is epsilon, and it represents factors that influence Y that we don't have data for. So same thing when we learned about correlation, that model only explains so much, and then there's this much that's unaccounted for. And that's captured by this term right here. So what things besides advertising might influence traffic in a yarn store on a particular Saturday? Well, here are a few. It could be that weather is just bad, like maybe it's raining and nobody wants to go out when it's raining, or maybe it's storming, right? So weather could definitely have a factor. And then maybe the time of year. If you're having this sale, like say, so I'm recording this in an April, well, maybe people might not be running to the stores because when you think of yarn, you might be thinking sweaters and mittens and things like that. And it's not really the season for that, right? Now, maybe if it's later in the summer or early fall, then yeah, that sale or that advertising might do more to influence traffic. And then another one would be other sales. Maybe other things are going on. Maybe a competitor is having a sale and it's better or something, or more convenient. For example, Walmart, they sell yarn, right? So maybe they're having a sale and that's just where you'd rather go, your customers, instead of going to your store. So lots of different factors unaccounted for, and that's what this epsilon is for. This is referred to as the error term in the model. Now let's go back to our prediction model for a second. So here it is right here. You've seen this before. This shows there's a relationship between advertising and traffic in the sample because we have a 0.35 in the slope. And whenever the absolute value is greater than 0, then we know there's a relationship. Now, as mentioned already, that's a sample, but we're interested in knowing whether this holds true also for the population. Because is it error, or maybe it really is what's going on, right? So we need to do hypothesis tests to find out. And the two tests involve looking at the estimates for A and B. So we have the hypothesis test for the intercept, and then we have the hypothesis test for the slope. A, the intercept in the sample, is the estimate of alpha, which is the intercept in the population. And then B, the slope in the sample, is the estimate of beta, the slope in the population. So for our hypothesis test for the intercept, we're saying that the null hypothesis is that alpha equals 0. So another way of putting this is the intercept in the population equals 0. And then the other hypothesis test involves looking at the slope, whether beta equals 0 or the alternative is that it's not. So the slope in the population equals 0. And the statistical test for both of these is a form of the t-test, and the degrees of freedom is n minus 2. And we'll save that for the next video. Let's talk about one more item here. We often care more about the hypothesis test for the slope than the hypothesis test for the intercept. All right, with that information, let's look at the R output in the next video.